Hello students, today's objective is very similar to the last one. Today's objective is students will be able to, identify graph and write equations of perpendicular lines. Okay. Alright, perpendicular lines are lines that meet, let's redo that. So there are lines, the definition is lines that cross and form a right angle. Okay, and we know a right angle also is 90 degrees. Okay, so a picture of these, and I'm going to draw mine kind of sideways, you can draw it any way you want, is that they cross and they form a right angle. Now, it is really important, just if you have something that crosses that looks like a right angle but doesn't have the right angle symbol, you're going to learn in geometry next year, you cannot assume that those are necessarily right angles. You need proof. And this, again, little kind of box is just showing that yes, it is indeed a right angle. Okay? Alright, we're going to work quicker through these. Okay, again, we're going to work quicker through these because this is very similar to what we did yesterday. Okay, so the first thing says find the slope of each line right away, and in my head I'm thinking m equals, and I should write that down. Okay, go ahead and hit pause now. Find the slope of these two lines. Hit pause now and do that. Okay, you should have similar work to mine, and you should have found that the first slope, so the slope of line mn, okay, is equal to a negative 7/4. Okay, if you got that wrong, make sure you go back and find your mistake. And again, I showed my work so you can look at my work. I have the xy1 up here, xy2 up here, plugged it in, found my slope. The line of OP here, okay, is 4/7. Now, the key to this, you cannot, if you left your answer as 8/14, okay, you need to write a big note, maybe with a pen, that you always have to see if you can simplify slopes. You cannot leave 8/14. Okay, so first question, are the slopes the same sign? The answer, no. Okay, clearly this one's a negative here, this one's a positive. Okay. Next, compare the relationship between the fractions of the slopes. What are the fractions called? Okay, well, first of all, if the signs, let's go back here, the slopes are the same sign, no, let's write that they are opposite signs. Okay, we had one that was a positive, one that's a negative. Those are called opposite signs. Okay, next, compare the relationship between the fractions of the two slopes. What are the fractions called? Okay, so let's ignore the signs for a moment, and we see that this first one is 7/4, but the second one was 4/7. Okay, what are those two things called? Well, fractions that are just basically flipped are called reciprocals. So compare the relationship between two fractions. What are they called? Okay, fractions are reciprocals. Let me make sure I get the spelling right. Reciprocals. Okay, that's the name. So I want you guys to really underline opposite and reciprocals, because those are key. Okay, let's go on to the... Okay, so now it says use the ordered pairs to graph lines MN and line OP. Label each line. Okay, so go ahead and pause now. graph these two ordered points, connect the lines, graph these two ordered points, connect the lines. So hit pause now and do that. Okay, if we look at these two lines, your graph should look the same. Okay, you might not have it color-coded, but you should definitely have it labeled. Go back here. You should definitely have these lines labeled with OP and MN. Okay, if we look at these, okay, and we can't tell just by looking, but I'll tell you this because I know the rule behind it. Okay, these two lines do in fact form a right angle. So let's put that, you know, kind of little square in there to show that they do in fact form a right angle. Okay. Alright, so let's move on down here. Okay, so lines MN and OP are called perpendicular lines. Okay, so write in the blank, they are called perpendicular. And you have to memorize what perpendicular lines are, because when they intersect means cross, again we have to get terminology down. They form a, let's write the word right in here, but they also, let's write 90-degree angle. Okay. Okay, let's skip to down here. It says perpendicular lines have slopes. Okay, have slopes, so we're focused on the slopes. I'm thinking back right now to what I already discovered about their slopes. Okay, so the slopes were opposite signs. Remember, if you go back to the previous page, you'll see that the one was a positive, the one was a negative. So they're opposite signs, and what do you think that last one is? What else was true about those fractions? They're not only opposite signs, but they are, okay, you should have realized they are reciprocals of each other. Okay. All right, now, this next part is a little bit different than the parallel lines. Okay, so I want us to come back and look up here. So I'm focused on this last part, perpendicular lines blank or blank blank that have the same y-intercept. So we're focused on the y-intercepts. Okay. Now my question is, do they have the same y-intercepts? And in this one, and again you guys don't need to write this on here, on this one you can clearly see no, they don't have the same y-intercepts. Okay, but you could have, okay, let me just give you a very simple example. Right, if we had something like this and like this, I'm going to make these a little bit darker so you can see them, and these were lines, right? These were equations. Okay, are these two sets of lines perpendicular? Yes, they are, right? They form a right angle here. Okay, but think about the y-intercept. Do they have the same y-intercept? And the answer is yes, they both cross the y-axis right there, right? You could also think of an example like this. You could have something, again, you guys can just watch this. You could have lines that look like this, okay, that form a right angle. Okay, do they have the same y-intercept? Yes, they do, right there. Okay, so what we're going to say for this last blank, okay, is perpendicular lines may or may not have the same y-intercepts. Okay. They can, but they don't have to. Again, we showed up here. Our first lines did not. Okay, our first lines did not have the same y-intercepts, but we can show perpendicular lines like these two that clearly do have the same y-intercepts. So again, perpendicular lines may or may not have the same y-intercepts. However, this is really important. We cannot assume the same. We cannot assume it. So basically all that means is that we still have to find B. We can't assume B is the same. Okay, let's go on to the next page. Okay, let's work on, so when you are working with perpendicular lines, if you ever see the word perpendicular lines, okay, here are the two words that should be going through your head. Finding the opposite finding the opposite reciprocal. Okay, perpendicular lines, you should be thinking opposite reciprocal. Okay, so let's go through a few examples. Example 1. First thing that we need to do, and here are some notes to remember, to finding the opposite reciprocals. Okay, make sure it's a fraction first, because you can't flip a number if it's not a fraction, right? You have to have a numerator and a denominator. Okay, and then all you're going to do, flip it, change the sign. That's it. So if we look at example 1 here, okay, it's not a fraction right now, but I can easily write it as a fraction, 2 over 1. Okay, so that's, again, I can write any number over 1. So right now, that is 2 over 1. How do I do the opposite reciprocal? Well, I flip it first, so it would be 1 over 2. Again, the 2 was in the numerator, now it's in the denominator. The 1 was in the denominator, now it's in the numerator. Flip it, and this one was a positive, so it becomes a negative. That's it. Simple. Okay, any number. Okay, any number, even a negative, we can write over 1. Okay, what would be the opposite reciprocal? Well, it was 5 over 1, so now it's got to be 1 over 5. Again, flip the fraction. Okay, and then it was a negative, so now it is a positive. Okay. Next one, simple. And again, I'm not putting equals because they're actually not equal at all. That's why I'm putting this line, okay, or the arrow. So it was 1 over 3, so it's got to become 3 over 1. It was a positive, so now it's got to be a negative. Okay. Example 4, okay, it was a 1 over 3, so now it's got to be 3 over 1. It was a negative, so now it is a positive. Okay. We could also just write that as 3. Okay. All right, 0 over 3. Okay, if we flip it, it would be 3 over 0, and then we'd have to change the sign. Okay. But keep in mind, anything over 0. Okay, if 0 is in the denominator, we know that we can't have that, right? If you do it on your calculator, you're going to get an error. Okay, you're going to get an error. And if we're talking about the slope of this, like if we were looking at the slope, if 0 is in the denominator, write that down what that would be. Is the slope 0 or undefined? Okay, remember, if you get an error on your calculator, the slope is undefined. Okay, the slope is undefined. All right, take a minute or two. I want you to do these next problems, finding the opposite reciprocals of each of these. Now, perpendicular slope, again, we know that the slope of perpendicular lines is just an opposite reciprocal. So all you have to do, flip the fraction, change the sign. Okay, hit pause, do that now. Okay, here are my answers. Double check yours with mine. Many mistakes, make sure you count them wrong. That way when you're studying, you know which ones to go back and prioritize. Okay. Otherwise, let's go on to the next slide. Okay, graph the following equations on the same graph. Okay, line DE is y equals 3, and line FG is x equals negative 3. Okay, I want you guys to graph both of these equations on this graph now. So go ahead and hit pause and do that. Okay, you should have looked at these and seen whenever, and this is so important that you memorize this and understand it, whenever you have y equals a number, whenever you have y equals a number or x equals a number, we know that they're going to be vertical or horizontal lines. Okay, we know that. Okay, so how do we determine which type of line it is? Well, you just look at what it says. Y equals a number, right? So which axis do you think it's going to cross? The x or the y axis? Well, it's going to cross the y axis. So the first question you ask yourself is, which axis does it cross? Tells you right there, the y. Second question, well, where does it cross? Also tells you right there. Crosses at positive 3. Okay. Now, if it only crosses the y-axis, okay, we know that it has to run like this. It can never cross this x-axis, right? And the only way for it to never cross the x-axis is to run parallel to it. The other way of thinking about this, and you don't have to get this down in your notes, the other way of thinking this next part anyway, you don't have to get down. The other way of thinking about this is that no matter what ordered pair you have, okay, any of these ordered pairs, the y value in that ordered pair is always 3. So in your xy, the y value is always 3. And this can be any number. Okay. So if I go left 4, so from the origin, if I go left 4 and get to here, what do I have to do next? Go up 3. If I go right 5, okay, what do I have to do to get back? Then my next move is to go up 3. Okay, so the y value is always 3. To graph the x equals negative 3, you just ask yourself, okay, well, which axis does it cross? Clearly the x axis. And where does it cross? Negative 3. So 1, 2, 3. So my line, ooh, that's a bad line. My line would be like that, and yours should be a lot straighter. You guys can use a straight edge on your paper. Okay. What is your conclusion about the lines with the equation y equals a number and x equals a number, or x equals a number and y equals a number? And the answer is they are perpendicular. Perpendicular. Okay. Got to sound those words out to make sure you get them spelled right. Okay, let's just do some quick practice. So this was line DE up here, because again, these lines are tricky. So what was the slope of line DE? Well, what is the slope of a horizontal line? Think about that. Remember, whenever you're thinking slope, you're thinking how much fun is it to ski on it. Okay, so write in the slope right now. You should have said the m is equal to 0. Okay, now what's the b? Well, where does it cross the y-axis? It crosses the y-axis right there at positive 3. Okay. All right, what's the slope of line FG? So this was line FG. What's the slope of a vertical line? Okay, you should have said the slope of a vertical line is undefined. I got to write mine below here. Okay, undefined. Remember, whenever you're thinking slope, you're thinking how much fun is it to ski on that? Well, if you are skiing on that line, you will go over the cliff and you will die. So you cannot even define how much fun it is because you're dead. Okay, so the slope of a vertical line is undefined. Okay, now, where does it cross the y-axis? So the y-intercept. And that line never does, right? So we say that the y-intercept on this, we just say that there is none. Okay, it never crosses the y-axis. Okay, so let's go on to some of the challenging problems now. It says, write an equation. Okay, this is what's going through my mind. Y equals mx plus b. Write an equation that runs perpendicular to y equals negative 1/2 x. Explain how you know it is perpendicular. Okay, all right. Perpendicular line. So that's their equation, right? Well, what's their m? Okay, their m is negative 1/2. Okay. Now, what do I know about my m if my line is perpendicular to theirs? Well, I know that my slope has to be the opposite reciprocal. So what's the opposite reciprocal of negative 1/2? Well, you flip the fraction, so it would be 2/1. Change the sign. So my m, and I'm just going to write this right here, my m is equal to a positive 2. Okay, so all you have to do is write an equation that has 2 for your slope. Y equals 2x would work. Okay. Now, could you add a y-intercept for this? And the answer is yes, you could, because you don't know if the y-intercept is the same or not. So you could leave it. So you could even do something like that: 2x minus 3. You could do 2x plus 5, whatever. Okay. Now that only works for this one because we're not given a point that our line goes through. So let's actually do a problem where it gives us a point that our line goes through. So write an equation in slope-intercept form. Again, right away, what goes through my mind as I read this, and I'm going to write it down, y equals mx plus b. Okay, that passes through 2, negative 4, and is perpendicular to the line y equals 5 minus 3x. Well, I don't like the way that equation is written because it's not really in slope-intercept form. So I'm going to start by changing that. Okay, my x term is negative. It's negative 3x. And then my 5 is positive, so plus 5. Okay, so here's how your work should look for this. Their slope, okay, was negative 3. And I'm going to write that as a fraction, right? Okay, well, what do I know about my slope? Okay, what do I know about my line? Okay, well, if my line is perpendicular, I know that my slope has to be an opposite reciprocal to their slope. Okay, so my slope would be 1/3. Again, opposite reciprocal, and let's write that in. Opposite reciprocal. Okay, that's a property that I know about perpendicular lines. So now I know my m, and I also know my line runs through these points. So now I know my x and my y. So I have y equals mx plus b. My y is negative 4. My m is 1/3. My x is 2. And then plus b. Again, I cannot assume I know what b is, okay, because it may or may not be the same y-intercept. So then if I simplify, let's see, that would be 2/3, and you can do that on your calculator, plus b, okay. And then to solve for b, I need to subtract 2/3 from both sides. Again, and you can do this on your calculator. So my b is equal to negative 4 2/3. Okay. Now I know my m. Okay, now I know my m. Well, I did know it. And now I know my b. So now I can write my equation. Y equals, my m was 1/3 x. My b is minus 4 2/3. Okay, that is my equation. So again, to recap, okay, I know that my line is perpendicular to theirs, and my line also goes through this point. Okay, well, if I know their line, okay, it has a slope of negative 3. Therefore, my slope, because I know mine is perpendicular, has to be the opposite reciprocal of theirs. Okay, so that's how I figured out my m. And then it's just back to what we did in a previous objective where, okay, now I know my m and I know a point. I can plug those 3 pieces of information in and solve for b. And then I have my m and my b, so I can easily write my equation. Okay, let's go on to the last slide. Okay, so it says write an equation in slope-intercept form. Slope-intercept form, I'm thinking y equals mx plus b. That passes through, so I know where it passes through and is perpendicular. When I read that word perpendicular, I'm thinking opposite reciprocal to the line described by this. Okay. Now, one real quick thing. In order to find their right, we have to know their slope. Okay. Well, this equation does not give us their slope. So what do I need to do to find their slope? I need to convert it to slope-intercept form. So to do that, I'm going to subtract 4x, subtract 4x. Okay. I'm left with, do not forget that sign, negative 2y is equal to, I'm going to rearrange it right now, it's a negative 4x, and then it's a minus 6. Okay, and then to solve for y, a negative 2 is touching it, so I need to divide by negative 2. I'm going to divide both of these terms by negative 2, by negative 2. So y is equal to, because that cancels, negative over negative is a positive 2x. Negative over negative is a positive 3. Okay, so now I know their m. Right? Their m is 2. So what do I know about my m? Well, if their m is 2, and we could write it as a fraction, my m is the opposite reciprocal. So what is the opposite reciprocal of 2 over 1? Well, it would be 1 over 2, and there was a positive, so now it is a negative. So now I need to write the slope-intercept equation, plugging in my data. Y equals mx plus b. Okay, I know 3 pieces of information. I know my x, I know my y, and I know my m. So negative 2 is equal to negative 1/2. My x is 3. That's an ugly 3. And then plus b. Okay, simplify. Negative 2 is equal to, if you do it on your calculator, you're going to get negative 1.5 plus b. How do you get b all by itself? Well, I have a negative 1.5 hanging out over there with it, so I need to add 1.5 to both sides. Okay, so b is equal to a negative 0.5. Okay, now I know my m, and now I know my b. So I can easily go back and say, okay, well, I can write my equation. My equation, and I'm going to write it just up here because I'm out of room. My equation would be y equals negative 1/2 x minus 0.5. Or you could say minus 1/2 would be fine too. This is your answer. I just wrote the slope-intercept equation of my line that I know is perpendicular to their line right here. Okay? Alright, if you have questions about that, make sure you hit pause and write what questions you have. Okay, last problem. Given the graph below, first write the slope-intercept equation. Then find the equation of a line that is perpendicular, again opposite reciprocal is going through my mind, to the one graph and has a point of that. Explain how you know. Okay. Alright, so to write the equation of any line, I first have to find the slope. So I need my points. And it looks like my points would all be right here. So it's a positive slope, my rise over my run, and again it's positive, so it's going to be, now I need to make my triangles. Hopefully your triangles are better looking than mine. It's always going to rise up 2 and go over 1, so 2 over 1. My b, it crosses at positive 5. Okay. Well, same thing, it just looks different. This is their slope, because that's their line, right? Their m is 2 over 1. So what's my m? Well, my m is the opposite reciprocal. So it was 2 over 1, so now it's 1 over 2, negative. Okay? And, oh, we didn't, so their equation, we didn't write that out, was 2x plus 5. Okay? So now I got to find my equation. My points, I know my line goes through those points, so I'm going to plug in y equals mx plus b. Okay, so my y was 1 is equal to, my m is negative 1/2, my x is negative 2 plus b. Okay, so 1 is equal to, negative times negative is a positive. Half of 2 is 1, so plus b. What's going on the same side of b? Well, I have a positive 1 hanging out over here, so I need to subtract 1, subtract 1. So my b in this case is equal to 0. Okay. So now I know my m, and now I know my b. So my equation would be y equals negative 1/2 x, and then do we need to show that plus 0? Answer, absolutely not. So that's my equation. perpendicular to theirs. And if I graph it, it's going to cross, I'll graph it in red here. It's going to cross the origin, right? The y-intercept is 0. And then the slope is going to be negative 1/2. So I would go up 1, left 2. Up 1, left 2. Down 1, right 2. Down 1, right 2. Does this line look like it's perpendicular to this one? And the answer is yes, it does look like it. So that's kind of a check to make sure it checks out. Okay. All right, want you guys to finish the guided practice problems for this objective before you come to class. Opposite reciprocal slopes, same process as our objective yesterday.